Hi everybody, and welcome to Backer Breaks It Down. In this episode, we continue to look at Pythagorean theorem, but I want to look at its converse and something called Pythagorean inequalities. So remember, Pythagorean theorem works for right triangles. So we know this to be the Pythagorean theorem, a squared plus b squared equals c squared. Okay, and that works for right triangles. So Pythagorean inequalities allow us to still compare leg squared plus leg squared to the what could be hypotenuse squared and determine, like, is the triangle a right triangle or is it acute or obtuse? And so if you look at these rules here for acute, right, and obtuse, right, you'll notice that they're comparing the value of c squared to the sum of a squared plus b squared. So in order to use these Pythagorean inequalities, c is the length of the longest side. So you're comparing the longest side squared to the sum of the squares of the other two sides. And if c squared is less than, it's acute. And if it's greater than, it's obtuse. And of course, if it equals, it's right. And so like here, they're like, all right, consider a triangle of 6, 5, and 10. So 10 would be side C because it's the biggest side. And so they've calculated c squared and they got 100. They calculated a squared plus b squared and they got 61. And so 100 is greater than 61, which means the triangle's obtuse. Okay, so what about this triangle here? It says consider a triangle with side lengths 5.3, 6.7, and 7.8. Is the triangle acute, right, or obtuse? Okay, so in order to use these inequalities properly, remember C has to be the length of the longest side. So that means that would be the 7.8. So I want to compare 7.8 squared to 5.3 squared plus 6.7 squared. So I need to do these calculations so that I can actually figure that out. And so naturally I did that. So I got 60.84 over here. And on the other side, I got 72.98. So c squared is less than a squared plus b squared, which makes this an acute triangle. And so that's how you can use side lengths to classify a triangle by its angles. Pretty cool, huh? Remember, C has to be what we're considering the longest side in order to do this. And that's how Backer breaks it down.